Welcome back. In this video, I'm going to extend upon our study of three-dimensional figures from prisms to pyramids. Here's a few examples of different kinds of pyramids. Here's a pyramid with a square base. I have a pyramid with an octagonal base and a pyramid with a triangular base. Okay? And a pyramid, as you may have noticed, has only one base. And it can be any type of polygon. It's usually a square, the most common kind of pyramid. Pyramids are named by their bases. As you saw here, I named my pyramids based on the kind of base it had. And a regular pyramid has a regular polygon as its base. So we could have lots of different kinds of polygons for our bases. Again, most of the time it's a rectangle or a square or a regular polygon. The edges of a pyramid, these lateral edges or the edges of our lateral face, meet at a single point called the vertex. And the lateral faces of our pyramid is always a triangle. Okay, so even with my octagon base, my faces are all triangles. I have 8 triangles here on that octagonal pyramid. A regular pyramid would then have a regular polygon as its base, and the lateral edges are all going to be congruent. And that does make sense. If my lateral edges are congruent, then the lateral faces are congruent isosceles triangles, which also makes sense. We've got isosceles triangles here, and they're all going to be the same. The altitude of our pyramid is going to be the perpendicular segment from the vertex to the base. So the altitude extends from the vertex like a fire pole right through the middle, hitting our base directly in the center. And of course, it's an altitude, so it forms a right angle. It's perpendicular to the base. Each of our lateral faces then has what we call a slant height. And the slant height is the perpendicular segment on the lateral face. It's the height of the lateral face. So if this is a isosceles triangle, then this slant height will also be a median. It will divide the bottom here into 2 equal parts. But what you're going to find with our pyramids is that our altitude, so the point extending from the vertex to the center, and the slant height will form in 3 dimensions inside of our pyramid a right triangle. So we'll have a leg of the right triangle from the altitude to the slant height. The slant height will be the hypotenuse, and the altitude will be another leg. So once again, watch your Pythagorean triples when working with surface area of pyramids, and watch for your Pythagorean specials, your 30, 60, 90s, and 45, 90s. So we have an example here below where we want to calculate the lateral area and total area of the pyramid. I did leave out one important piece of information, or several, but here's one. This is going to be a square pyramid. So we know our base is a square. So we can put some labels on here real quickly. AB is our altitude, AC is our slant height. Put the vertices of our square base, and we've got some labels to work with. So we've got a slant height of 15, so AC is 15, and our altitude AB is 9. So if our altitude is AB, that's going to form a right angle. Doing our Pythagorean triples, we've got a 3, 4, 5 up here in 3 dimensions, formed by our altitude and our slant height. So BC must be 12. Side BC of that triangle must be 12, 9, 12, 15. Which means MU, or the side of our pyramid, of our base, must be 24, because it's going to be double the 12. So each side is 24. Well, now I have enough information to calculate the area of my pyramid. My area is going to be the lateral area, which I'll abbreviate LA, which is my 4 faces, plus the area of my base, of my square. So, well, the area of the base, my square, that's going to be pretty simple. That is 24 squared, or 576 square units. Now I need to add that to the lateral area of my faces. Well, the 4 faces of our pyramid are all the same, so if I find the area of one of the triangles, I can multiply it by 4. So I have 4 times, and then my triangle, 1/2 base times height, 4 times 15, and there I've set up exactly how I'm going to find the total surface area, the lateral area, plus the area of the base. So 1/2 times 4 is 2, times 24 times 15, and 2 times 15 is 30, so I have 30 times 24, plus my 576, and 24 times 3 is 72, so 24 times 30 must be 720, plus 576, and I get 1,296 units squared for my total surface area of my pyramid. And you'll get more practice with this, with some additional problems and challenges, when I see you in class.